How is the steel joined to the concrete in reinforced concrete?
Well, what we need to remember is that we have produced a new composite material of concrete and steel. And in order for the two materials to work together properly, they have to be attached to each other. In other words, they have to grab hold of each other. So how do they grab hold of each other? They need to be bonded together. There are two types of bond mechanism which I'd like to talk about. One is chemical bond and one is mechanical bond. The chemical bond between steel and concrete can be thought of the cement in the concrete as it were gluing itself to the steel bar. That's one type of bond. Another type of bond is mechanical bond. And what we do is we help the steel greatly in this, in getting that mechanical bond. This is a deformed reinforcing bar. And what we mean by that is it has these deformations, these ribs along its length. And you can imagine that if this bar tried to pull out of concrete, then the concrete which sits between those ribs would prevent it from happening. Those ribs really help with that frictional resistance. But there's another way that we can help with mechanical bond, and that is by bending the end of each of our steel bars so that they look a little bit like this. And these bends at the end prevent the bar from slipping, and they can be thought about, if you like, as being handles on the end of the bars to prevent it slipping.
Why do we use steel and not another material to reinforce concrete?
Well, steel is an absolutely wonderful material in tension. It's incredibly strong. But there are three other really good reasons why we use steel and no other material to reinforce concrete structures. The first one is to do with thermal behavior. If we have a reinforced concrete bridge standing outside, of course, in winter the temperature will be low and it will contract, and in summer the temperature will be high and it will expand. And what would be a disaster would be if the concrete and the steel expanded and contracted by different amounts. And by chance, they expand and contract by exactly the same amount. So that's a wonderful attribute which has been discovered by chance. The second one is to do with the pH environment of the concrete. Steel will corrode very, very quickly in an acidic environment. But wonderfully, concrete is an alkaline environment, a highly alkaline environment, which means that it protects the steel from corrosion. Thirdly, there is another attribute which has been discovered by chance as well, which is that when we have a reinforced concrete structure, of course the top goes into compression, the bottom is stretching, the steel at the bottom is stretching. And it turns out that the amount that the concrete crushes at the top and the amount that the steel stretches at the bottom are beautifully tuned to each other so that we use the two materials efficiently when we get close to failure.